These are the notes for Algebra 2, Section 4.6. We're going to start talking about complex numbers. Complex numbers might seem strange when we first start dealing with them, but as we look at them more, they'll start to make more sense. Before we get started, though, we need a little bit of vocabulary. We're going to begin with just a basic idea. This is that the square of any real number is always positive. And we know this. We've seen this before. We know that if I have 2 squared, for instance, that is 4. We also know that if I were to square negative 2 squared, guess what? I still have positive 4. So it doesn't matter if a number is positive or negative. When I square it, it always ends up being positive. And that is true for any number that you can think of. Any, positive 1, negative 1, positive 0.5, negative 0.5, whatever you can think of. Those numbers, when you square them, are always positive. This leads us to a very interesting problem. Because if the square of any real number is always positive, we're not able to take the square root of a negative number. For instance, if I wanted to take the square root of negative 1, here I have x squared equals negative 1, so I would need to take the square root to get x by itself, like we've seen. When we do that, we cannot actually take the square root of negative 1, because there is no number I can multiply by itself to get negative 1. It doesn't exist. So, mathematicians, being the creative bunch that they are, invented the imaginary unit I. Now, it was created so that we can solve quadratic equations like x equals the square root of negative 1. Now, the imaginary unit I is defined as I equals the square root of negative 1. And I squared equals negative 1. So I is the only number that you can square and get a negative. That makes it imaginary. It's not a real number. It's an imaginary number. Now, before we go jumping off into the distance of why we have imaginary numbers and real numbers, the imaginary part of imaginary number doesn't mean that it doesn't exist. All right? Imaginary number I shows up in physics, real-world applications all the time. It's just that since it's not technically a real number, we call it an imaginary number. Just a naming convention. It doesn't mean that I doesn't actually exist. Now, we know the imaginary unit I is the square root of negative 1, or I squared equals negative 1. So let's look at how this actually works. If we want to take the square root of a negative number, here's what happens. If r is a positive real number, then the square root of negative r is equal to I square root of r. So what we've done is removed the negative sign and put I in front instead. So, for instance, square root of negative 3, we take this negative sign here, we remove it from underneath the radical, and it becomes I. When we do that, we get I square root of negative 3. The negative sign is removed, the 3 is left, and I sits out front. Now, using that property, we can expand it just a little bit and look at what would happen if we squared the square root of r squared. If we did that, we would get negative r. And again, here's how. If I squared I square root of r, what I would be doing is squaring the I and getting I squared, and squaring the square root of 3. Now, of course, the square root of 3 squared is 3. And we've seen that before. Well, I squared, by definition, is negative 1. So I squared times 3 is negative 1 times 3. Negative 1 times 3 then is negative 3. And that's how we get there. So that's just a useful piece of information to have. We have I squared equals -1, and we can multiply it together to get -1. Now the main way that we are going to use the imaginary unit I is part of solving equations using square roots. Because every once in a while we might come upon a quadratic equation that wants us to take the square root of a negative number. And we need to be able to do that. So, looking at example 1, that's exactly what's going on. We need to solve this equation using square roots, and I would be willing to bet you that we're going to need to take the square root of a negative number at some point. So, to start off with basic solving equation stuff, we begin by subtracting 15 on both sides. Gives us 2x squared equals -35 minus 15 is -50. Then we divide by 2. Gives us x squared equals -25. Now, this is where it gets interesting. We have to take the square root of both sides, right? We need to get rid of the square in front of the x. Taking the square root does that. Gets rid of that square. Leaves us with x. The square root of -25, though, presents a problem. We are not allowed to take the square root of a negative number. So we need to remove the negative sign, and when we do, it becomes I. So we have I square root of 25. But of course, the square root of 25 is 5. We know that. So really, this is positive or negative. Since we took the square root, it has to be positive or negative. 5i, because the square root of 25 is 5. The I, you'll notice, didn't go away. It never goes away. It's a term that has to stick around. What did happen, though, is we put it at the end. It's kind of a convention that if I have a radical, I put the I first. If I have a whole number, I put the I after it. All right, that's just a convention that we use to make things a little more organized and easy to see. All right, now the next thing we might need to do with a complex number or an imaginary number is perform basic operations. Now, a complex number, this is another definition for us. A complex number is a number a plus bi. You know, this is a whole, it's basically a binomial. A plus bi. The a is the real part. That is, it's a real number. It's not an imaginary number. Like, it doesn't have I in it. And the bi is the imaginary part, called the imaginary part because it's the part that has I. I is a lot like x in some ways, in that if two terms don't contain I, they can't be combined together. All right, like terms have to be combined with like terms. That's a normal rule. We're used to that. So when we add or subtract, if we want to add or subtract two complex numbers, we have to add the real parts, and we have to add the imaginary parts separately, on their own. Let's just say on their own. Right? We want to, and the reason why we need to do it on their own is because we have to take all of the real numbers, add them together themselves. And we have to take all the imaginary numbers and add them together all on their own. Then we can combine everything together into one complex number. And let's see how we do that. Now I want to write 6 plus 3i minus 4 minus I as a complex number in standard form. So here's what we do. We look at our numbers and we say, okay, well, I have this real part 6, this real part 4. I have this imaginary part 3i, and this imaginary part, negative 3i. Now I have to add, or I have to combine the 6 and the 4. What I'm actually doing is subtracting. You'll notice that's a subtraction symbol. So in this case, I'm going to subtract 6 minus 4. And I'll just write 6 minus 4. And I need to subtract the real part, or the imaginary part on its own. So I need to subtract 3i minus negative I. Right? This is negative I, so we're subtracting negative I. Now what we're actually doing is we have to put a plus in here, and just for a moment I want to take a second here. It doesn't matter what operation we're doing on the complex numbers. Okay, it doesn't matter if we're adding or subtracting. When we get to this stage, this should always be a plus sign, always. So don't worry about the fact that I'm subtracting here and I end up with a plus there. It's always going to be a plus sign there when I'm adding or subtracting. That's just across the board. Now, let's subtract the real parts and the imaginary parts on their own. So I have 6 minus 4, that's the real part, and that's 2. Have that plus sign. I have 3 minus negative I, well that's the same thing as 3 plus I. The imaginary part on its own is 4i. So when I combine them, just like combining like terms really, I end up with 2 plus 4i. Same thing with addition, same basic idea. We have a real part 2, a real part 7. We have an imaginary part 5i and an imaginary part negative 2i. Now we're adding here, so we need to add the imaginary parts together, and we need to add the real parts together. The real part 2 and 7, the imaginary parts 5 and negative 2, 5i and negative 2i. And we're going to do them separately on their own. So I'm going to add 2 plus 7. Notice that I have 2 and 7, right? It's positive this time. We're adding 2 and 7. And I'm going to add 5i plus negative 2i. Okay. And again, it doesn't matter that this is plus in the middle here. The sign in between these two is always going to be plus. So we just don't even need to worry about it. Alright, 2 plus 7 is 9. We know that. 5i plus negative 2i is 3i. That means that when I add 2 plus 5i plus 7 minus 2i, I get 9 plus 3i. Again, just like combining like terms, really. It's just we have an I instead of an X. Now, the last thing we might be asked to do is to multiply two complex numbers together. Right? We might have to multiply a couple of complex numbers. As I said at the beginning, complex numbers, they kind of look like binomials. That means that if I want to multiply a couple of complex numbers, I'm going to multiply them basically the same way I multiply binomials. I can either use FOIL or I can use the box method. I'm going to use the box method, just because that's what we used when we multiplied binomials. So I'll put 2 and plus I along the top, negative 5 and 2i along the side, and I will fill in my box. Negative 5 times 2 is negative 10. Negative 5 times I is negative 5i, just like if it was x. 2 times 2i is 4i. And 2i times I is 2i squared. Now, here's where things get interesting. I love saying that. Of course, these two guys here can combine just like they did with binomials. I end up with negative 10 minus I, because negative 5i plus 4i is negative 1i, plus 2i squared. But we've seen this before, this I squared. it was one of our definitions. I squared equals negative 1. Means we're not quite done here. We still have negative 10, we still have negative I, but now we have 2 times negative 1. All right, so when we work this out, negative 10 minus I, 2 times negative 1 is negative 2. Well, it should come as no surprise that I can combine negative 10 and negative 2. When I do that, I end up with negative 12 minus I. Notice I put the I term last. Again, the imaginary numbers are always in the real part first, the imaginary part second. So when I multiply these things together, I should end up with a single imaginary number, not a string of imaginary numbers, because this last term here is always going to end up just being negative, right? Because the I squared is negative. And that's going to be consistent across every single problem that we do when we multiply. Now you have some practice problems at the bottom of your note guide, so you can give those a shot and bring the completed notes into class with you.